Hello again, folks. Welcome to our video number 4. This is going to be on isolators. Isolators are one of those devices that are all over the addressable buildings, and they're a device that a lot of guys know how to test them. There are a few guys that are intimidated by them, and it's something that shouldn't be intimidated. They're worried about possibly shorting the wrong wire and causing a problem in the panel, or destroying the isolator or something back in the panel. So the guys are a little bit intimidated on fault isolators. Now isolators are very easy to test, and they're very straightforward. What an isolator does, for anyone that doesn't already know about an isolator is to take a section of a building and isolate that from the rest of the building. Okay, so what happens here is that when there's a fault in this section of the isolator, between isolator 1 and isolator 2, any device in between, if there's a fault in a short on one, then this whole group is isolated, they no longer work, but the rest of the building continues to work. So an isolator is designed to verify that it's doing that job. Now that being said, if you have an isolator and you're using the panel as its isolator in and out going through, because it's a small building, be aware that when you lose one short on one device, you've lost the whole building. Okay? So this is something we discovered in the process of setting this whole panel up, is that when we didn't have multiple isolators, the panel's own built-in isolators do the same thing. Once there's a short on the system, it takes the power off that. Now I don't know, some of the guys may have got smaller buildings or stuff, but if you don't have any field isolators out there, if you have one short in any of your devices, you no longer have a fire alarm system. It just will never go off. There's nothing to tell it to go off. You can pull a pull station, you can do heats, whatever you want, smokes. They will do nothing. There's no way to tell this thing to go once there's a short in the line, if you only have the panel as its isolators. So you may want to add in extra isolators. If they don't, it's a safety precaution for the building so that you can actually protect the people. Okay, now we're going to go on to here. So this one here, we are going to time this here. I'm going to show you. Now again, all isolators are typically at the ceiling, in the ceiling, on sprinkler devices, the rooms. So, but again, this is a controlled environment, nice and easy access. So when we show you the time, you have to add extra time to it in the field. Now, this test includes, okay, so the first device isolator coming into the floor, you're required to do an open test on that circuit and get the reading from the panel. Then you're supposed to go on the isolated side, and you're supposed to short that, and then test the device on the shorted side. It should not work. Then you go to a device outside the shorted side, and you test that one. It should work. That's correct. Then you put that isolator back together. Now you go to the other one, which is the isolator out, and again, you take the wires coming from that, we'll go to the panel, you do an open, verify that it works the opposite direction. Then you short the other side, again, test the device on here, verify that this does not work, test on the outside of it, it should work. Put this back together, your test is done. Okay? So this has to be done for every isolator. Every floor in and out has 2. Alright? In order to do this, we have set up the EVS switches. They're already done here. You are required to have 2 EVS switches to do 1 isolator test. It's just in the part of the circuitry. There's a jumper wire that has to go in one. You just can't do everything with just 1 switch. It requires 2 to get that done. So what we're going to do here is I'm going to go through the isolators, and I'm going to show you how it works. So we're going to set up our timer again. We're back to 0 time. And we're going to push start. So you're going to go up to your first isolator. Now this is labeled in. If it's not labeled, you're going to have to figure it out, and then you're going to have to label it. Every device is supposed to be labeled to tell you what's going on. So in this case, these are small little screws. The guys lose them all the time, they fall down. Now don't forget, if you're up on a ladder, you got to store these on a ladder, you got to put them someplace so you don't drop them all. Okay, so I would just put them in here. Now here's your isolator. Now you need a different screwdriver to get this off the back box. Okay, you pull this out. Now, this isolator says it's a system sensor, and it's got 1, 2, 3, 4. Well, now you need your instructions to know. Now here it says 1 and 2 is from control panel, is the control panel in. So then you need another screwdriver to remove number 1 wire. Let's remove it. You got your trouble. We're good? It's recognized as open. You put the wire back in. You don't need to read every single device that came in on the system. That is done. Now, you're going to want to have some jumper wires. Okay, the alligator kits are best, but if you don't have them, in which case I don't happen to have them, we're just going to stick this jumper wire in here, tighten it back down, and on some panels you have to do a reset in order for the loop to clear itself. Panel is clear. We're going to put this in here. Now we've introduced the short on this isolator, as indicated by this one here. So, now you're going to test your pull station. Before nothing worked. Reset this, this is correct. Now you go to a device outside your field, you're going to pull this one, and you got your alarm. To reset. Now you got to take your jumper wire back off. Again, make sure your wires don't fall out. A lot of times the alligator clips fall off, so I kind of like to use this the solid jumper wire because I don't have to worry about my jumper alligator falling off and go to the field that doesn't work. I wonder what's going on. Now you put it back together. These only go on one way. Oh, wrong screwdriver. Put your plate back on. Careful not to drop the screws, because then you gotta go find it. Especially hit the floor, they bounce all over the place and you can never find them. So you're going to want to carry a few of these extra little screws if you're going to do it the old way, because you're going to drop them all the time. Okay, that one's back together. Now we're going to do the next one. So this is your, that was your in. Now you got to do your out. Now hopefully when they made the building and put the fire alarm system, they used one manufacturer's isolators, so you know what's going on. So it should all be straightforward. This is a slightly different version of it, or model. Again, we still have 1, 2, 3, and 4, so we're going to take one off. Should give us our open. Addressable loop open, we got it. Put that back together. Now again, make sure these screws are tight. Don't over tighten, you don't want to break the screw. Now we got to do our short. Do our reset on this. Okay, so now we have our short. Now we pull the device on here. The device does not work. We can reset this device. We're going to stop this for a second. is this then should be lit up. So, 1, 2, is the wire not, why is that not lit up? Did I short the wrong one? Maybe that could be the, you know what? Let's just keep on going with this time here. Just in case this happened to be wired incorrectly. It still worked, but it didn't. I should have both LEDs lit up as I had in the first one. So we're now going to do the first one. And again, this is things you're going to find out in the field. If this is what happens, you got to figure this out. We're saying let's not have to do this every time. So this should, let's do a reset. Okay, so now we have both. Okay, so in this case, they reversed the wires going in it when it was set up. It still worked, but didn't recognize it. Okay, so now we pull this device here. This device will not go into alarm, which is basically now saying it's isolated. Put the back together. Pull your other device outside the loop area. That's your alarm. Okay, now we've done that. Get the right tool. Take this one off. Tighten it back up. Okay, so this one was labeled is in the other direction. So the guys are going in the field, they're going to have to figure it out. Now what the guys would normally do, if they're smart, is they would mark on the thing in a permanent marker which one is in and which one is out, and then they know what's going on. Because if you do the short at the end, you don't isolate the switch. It's only on the out that you get the isolation. Put this back together. Off the screw. Again, that screw only dropped, a foot here because we got this up in here and it's got a ledge here. But if I was out in the field, I'm going to find that screw now. And stop. We'll do a reset. Okay, so now, all things considered equal, I'm assuming that wherever this device is in that field, I have to get off my ladder and go do that test. The same thing with the EVS switch. Once I do click my switch to the right position, I still have to walk into that field and do that. So that time is equal. You can add that on to every one for doing the isolator test. But as far as getting into the isolators and doing what you have to do, we just spent 8.5 minutes to test your isolators, which is basically for 2 isolators. Now you've also got a guy at the panel for the same thing. So I don't know how many isolators you got in your building, but we're at 8.5. We're at 17 minutes to basically test a set of isolators. 17 minutes. I want you to remember that, 17 minutes. Okay? So, if we're going to do 17 minutes, let's just figure what that cost the customer. 17 minutes divided by 60 minutes times by $100 an hour, that's what you got. It costs $28 to the customer to test that device. Okay, so we're going to mark this down here because I'm probably going to forget about it. So 8.3 3 minutes, which is 17 minutes to do an isolator. At a cost of $28. Now, if your guys charge more than $100 an hour, or they charge less, you do the math, it works at the same. Okay, your panel's all set. I'm going to reset the timer so it's back to 0. And now we're going to do the offside EVS isolator testing. So, we're going to go start. I'm going to grab my key. Floor isolator open. Let's see. Open test. Here's the open. Test is done. Go to the short side. Again, panel's got to be reset. We did the last on that one there, so we'll do it here too. Okay, now we're going to go right to the short. We have isolator 1 and isolator 2 in short. That means this device should not work. And it does not work. No alarm. Okay, we now go to the device outside the field. We got our alarm. Okay, that's that one there. Do our system reset. So this isolator is back to normal. Now we're going to put it in the other one, which is our open test. Here's our open, it's already lit up on the panel. Q, put that back out. Now we're going to go over here. We'll do a system reset. Let's get it all back to normal. Panel's normal. We're going to go to the short. We now have our isolators lit up, which means this device should not work. That's correct. Pull this one here, the alarm should work. Okay, we'll put this back in. We turn our key back, stop. The guy at the panel will reset it. Okay, panel's back to normal. So, this one here took 2 minutes and 5 seconds to do that test. Times 2 guys, so that's 4 minutes. So, 4 minutes compared to 17 minutes, what's our cost on that? So, we got 4 minutes. Divided by 60 times by 100, $6.66. So you just saved yourself basically 22 bucks on the test of that. Now, that test is going to be a whole lot higher because you need ladders, you need other things to do that test, whereas with this you do not, okay? You can mount these in. Even if you wanted to mount your isolators, say they're at the ceiling, okay? So, what you can do, take your isolator box, you put an extension box onto it. You can do this in wire mold as well, it looks nicer and it's a lot cleaner. Then you get these little things here, they're offsets, 1/2 inch offset. You can mount the device like so, and then you can do another one down here and do them 2 side by side. Okay, I like to use the wire mold box. Okay, this one here happens to be the V5745, which has the knockout already in it. You just knock the knockout here in it, and now your wire mold goes right onto the box. I'm not sure if they make a 4x4 wire mold. I don't believe they do, so you have to put this on there, but you can put these on here and put 2 in. So this will allow you to quickly install these devices at the ceiling. Now, you go at the ceiling, oh, it's up high, you need a ladder. No, you don't need a ladder. A lot of guys use this solo testing stuff, and you may have extras of these things here, this little device here. Inside here, this little part here, it's just an Allen key holding it together. Take it out. Okay, I'm going to give you a better use for it, if you're not using them for it. So this is this little part right here. You take the Allen key out, or put your Allen key in there, and you put the key in here, just tighten it back down, and you now have your switch. So you just put this into your solo pole, whatever height that you need. And now, if this is at the ceiling, let's just put it down so you can see it. You're just going to put your key into here with your solo pole, click, 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 do your test, pull it back out. Okay? No ladders required. You got the perfect tool right here. All you have to do is insert the key and tighten it down, you're good to go. So you can walk around with your pole, so this thing could come out, and you could have this as your tool. Click, 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 turn on all the ones at the ground level. Anything up high, stick it in your pole, go up high, turn it, done, and carry on. Inspection done, huge. It's huge as how much time you can save on this. Okay, again, so the guys need to learn every isolator for every manufacturer, which one's in, which one's out, and any other special information they need on here. What we're saying is, let's stop doing all this every year. Read it once, install the EVS switch, label it, and then as soon as the guy comes next year, you just click, 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 and your test is done. Alright, so that's the end of isolators. Again, the instructions on how to wire them up are in the instructions, and that is it. Alright, thanks a lot.